So it says, what is the average of all 5-digit numbers that can be formed using each of the digits 1, 3, 5, 7, and 8 exactly once? So this question is like pretty weird, right? Pretty interesting. Like basically, if we have the digits 1, 3, 5, 7, 8, like we were to form all the 5-digit numbers with these digits, like 1, 3, 5, 7, 8, 1, 5, 7, 3, 8, like 8, 3, 7, 1, 5, 5, 3, 8, 1, 7 or something. And we form all possible 5-digit numbers with these 5 digits. And then like we continue this. We want to know what is the average of all of these numbers. So at first glance, this might seem like a very intimidating problem, but like the idea is like it's not as hard as like it might look. So the idea is like you actually want to like consider each place value separately, right? So we want to first look at like this column here. Want to first look at like the units digit column, then focus on the tens digit column and so on. So the idea is kind of like maybe if this is 5 digits, it's too hard to visualize, right? So maybe like let's simplify this down. Instead of 5 digits, let's look at 3 digits, right? Suppose we have the digits 1, 2, 3. If we were to like do the permutations of all the numbers we can form with 1, 2, 3, we have 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1, right? Those are all the possible arrangements of the numbers 1, 2, 3 you can have. So we're just looking at a simpler case right now. Instead of 5 digits, we're going to look at 3 digits to help us better understand what's going on in this problem. So the idea is kind of like, notice that like if we look at this column here, we have the number, we find that like the number 3 appears 2 times, the number 2 appears 2 times, and the number 1 appears 2 times. And notice that this is true for any column. So any column, you're gonna have like you're gonna have 2 3s, 2 2s, and 2 1s. So we want to like take advantage of this symmetry kind of. And notice that like if you like take the digits here, 3, 2, if you were to add up these digits, like 3 plus 2 is 5, plus 3 is 8, plus 1 is 9, plus 2 is 11, plus 1 is 12. And if you're to do 12 divided by these 6 numbers here, you get an average of like 2 kind of. So it's kind of saying like on average, this placeholder is going to be like this unit digit is going to have an average value of 2 kind of. Or you can alternatively, if you go back to this 5-digit scenario, what you can do is you can kind of notice that like, so as we saw in this 3-digit case, the numbers 1, 2, and 3, right? They appear like equally frequently, right? They all appeared exactly 2 times in each column. So, and that makes sense, right? Because there's nothing special about 1, 2, or 3. They're all digits. So it makes sense that all of them get like kind of like equal representation. They all like, they all appear the same number of times. So that's why if we look at 1, 2, 3, the average of the numbers 1, 2, and 3 is 2. And that's how like we get this average of 2 here in this units digit. So the idea is like, we have the digits 1, 3, 5, 7, and 8. So if we were to do the same logic we did with the 3-digit numbers, if we were to like make all the permutations, all the possible numbers with the digits 1, 3, 5, 7, 8, and if we consider, let's say, the rightmost column, like we did here in the 3-digit case, we consider the rightmost column. Each digit is going to appear the same number of times by symmetry, right? So by symmetry, the number of ones is going to be the same as the number of 3s, which is the same as the number of 5s, the number of 7s, the number of 8s. So the average value you can kind of think of in the units digit is going to be 1 plus 3 plus 5 plus 7 plus 8 divided by 5. And if you do that, that's like 24 divided by 5. So what this tells us is that like it's kind of saying for each digit, the average value is going to be 24 over 5. And notice that like you have the numbers we have here, like 1, 3, 1, 3, 5, 7, 8. If we continue arranging like 1, 3, 5, 8, 7, I don't know, like 1, 3, 7, 5, 8, 1, 3, 7, 8, 5, and so on. If we were to do all of these and add all of them together, right? We found that like for this column here, we found that like this digit, this number here, on average, it's going to have like a value of 24 over 5. This is what like our calculations here told us. Like, you know, on average, the numbers here are going to have a value of 24 over 5. Similarly, by symmetry, the numbers in this column are also going to have an average of 24 over 5. The numbers in this column are also going to have an average of 24 over 5. The numbers in this column are always also going to have an average of 24 over 5. And the numbers in this column are also going to have an average of 24 over 5. So essentially what this is saying is that like for each of these columns, on average, for the units digit here, for example, the tens digit, the hundreds digit, the thousand digit, the 10,000s digit, like each of these digits on average is going to have a value of 24 over 5. We found that just by averaging the numbers from like averaging the numbers 1, 3, 5, 7, 8, because we knew those were going to appear equally often in each column, because you know that's what we found with the 3 digits in this case. So remember that like in any like number, right? So if we have like a 5-digit number, remember that the units digit represents 10 to the 0. The tens digit represents 10 to the 1. The next digit represents 10 squared. Next one represents 10 cubed. Next one represents 10 to the power 4. Remember, like, for example, if we have like 7, 5, 2, 6, 1, then this represents we have 7 10 to the 4s, 5 10 cubes, 2 10 squares, 6 10 to the 1s, and 1 10 to the 0. So by similar logic, we can kind of pretend that like instead of like integers, we kind of have like, you can kind of think of it as like decimal digits. So like each of these placeholders, 24 over 5, it kind of has a digit kind of, you can say, of 24 over 5. So the total value of this expression is going to be 24 over 5 times 10 to the 0 plus 24 over 5 times 10 to the 1 plus all the way up to 24 over 5 times 10 to the 4. And this is going to be the average value out of all the numbers that you have. So you can kind of factor out a 24 over 5 out of all of these numbers, and you get 10 to the 0 plus 10 to the 1 plus all the way 10 to the 4. And you can calculate this is going to be 1, 1, 1, 1, 1 just by writing it out. So you can do 1, 1, 1, 1, 1 times 24, divide by 5. And, you know, the multiplications and the division is pretty easy, actually. And if you were to do the math, you would actually get choice C as the answer, 5333 2.8.